Thanks, everyone. So this is Pre2k, pre-Windows 2000 backdoors and bypasses. Real quick, who am I? My name is Garret Foster. I'm a senior consultant on the AdSim team over at SpectreOps. My Twitter, or my X now, is at Garret Foster. I don't post a lot of content, but I retweet a ton. So kind of on the agenda for today is I'm going to give you a little bit of background, kind of justify why we're talking about some accounts that have been around for since the 90s. Demonstrate a tool that I wrote called Pre2k, and then I'm going to share some other interesting research that has kind of come out since the development of this tool. So to begin the whole thing, we kind of have to talk about a blog post that was shared about May of last year called Diving into Pre-Created Computer Accounts. It was posted by Advar Mo over at TrustedSec. And to kind of give you the TLDR of that blog post, he pointed out that when you stage or pre-create a computer account in Active Directory, if you selected a radio for assign this as a computer account that's pre-Windows 2000 compatible, it's actually configured with a default password. So if you said if you selected that radio and named it computer, the corresponding password would actually be computer. So here's what that looks like. So if you were to create the machine, add the name, and then just select that radio, that's the only indication that you have that this is happening. And it's anytime afterwards, there's not going to be any indication that it's configured in that manner. So there's no warning, there's no nothing. It just creates it in that compatibility. So in his blog post, he pointed out different ways to try to find these things. And from what he had observed, he found that when you stage them this way, they're pre-created, they're not in use. So the logon count attribute and LDAP would be set to 0. He also found that the UAC value, the user account control value, would be 4128, which was for a workstation trust account and then not required password. But if you try to use a machine, so if you try to authenticate with the credentials of the machine account, like Pre2k, whatever it may be, you'd actually not be able to log in successfully until the password's changed. It would trigger an error saying no logon workstation trust account. However, what's interesting about them is that they're valid for Kerberos authentication. So with that kind of in mind, I'm just going to show you kind of what the workflow looks like of which if you were to create the account in that manner. So I'm going to try to use this demo. I don't trust myself to do it live, so we're going to roll through it. So you pre-create the computer, just navigating the Active Directory users and computers, assign the host name, and then just select that radio. So you'll see that as soon as I hit OK, that's it. It just goes away. So then I'll skip ahead a little bit. So I wanted to show you the attributes to kind of justify what Advar's conclusion was, because he's right. When you set them up in this manner, this is the identifying traits. So you'll see that the logon count is set to 0. We've not used it. It's not actively in use, connected to a machine in the domain. And then the user account control value is 4128. So the next step I want to show you is kind of triggering that authentication failure and where you get that status no longer workstation trust account error. So we'll use CME just to handle that quick and easy. So you'll see that authentication failed. So it's that same error that we kind of discussed. But then I'll switch to authenticating via Kerberos. So I'll just grab a Kerberos ticket granting ticket. And we'll just use the in-packet script get tgt.py to handle that for us. And you'll use the same creds that we discussed. So it's just the host name in lowercase. You just drop that $sign. So now we have a valid Kerberos ticket. So the machines are configured this way, and they're only valid over Kerberos. So this is relevant for this conversation because right around that same time, we were working for a client that had a pretty strict rules of engagement, and we've been doing work for them for years. So there weren't very many attack paths available to us. So the idea here was, okay, we had managed to come across a list of every computer in their environment, but we couldn't really do much with it. And we found Advar's blog, and we weren't allowed to password spray for reasons. So I posed it. I reached up to the POC and I said, look, it's not a password spray. It's a default credential check. It'll only be one guess. And it worked. So he said yes. And they gave us a green light. So we took that whole list of computers, concatenated it in the format that's expected. So hostname and then lowercase, and then loaded up Kerberoot because it's Kerberos authentication. So I'll give you the list. It was a list of all of it, and it was like 98,000 computers in this environment. So it was pretty large. So this is what the list looked like when we were running it. And then when we got the green light, we were like, cool, let's send it. And this is kind of what it looked like live. So if you were there with us, this was the result of running it, and it just blew up green. So that was shocking to us, and it was really confusing because the kind of like the premise of Oddvar's blog even was that this would be pretty rare and uncommon. So to have this many valids was shocking to us, and we actually had this wasn't the first try. We ran it once with only 10, and it came back with 8 valid, and I thought they were false positives. So we waited and ran it again, same 8, and then it was like, all right, cool, just send it. So in the end, after we let the whole password spray run, we had 1,100 valid machine accounts, which was confusing. So you see a number that large, you kind of like, all right, what's up? So I thought Oddvar was onto something with this and that there might be something else going wrong. And so I pulled back LDAP attributes for all 1,100 and just kind of looked for anomalies against what his conclusions were. And what I found was that the UAC values would be different. So we'd have ones that were like the default 4096 as if it were a domain joined machine. And there's 69623, which is a combination of those 2 previous and one other that I can't remember. But the most confusing thing was seeing logon count values greater than 0. So the whole idea here was that they were never in use. They were never joined to the domain. They were just stale objects sitting there. So the next kind of stage in this process was, all right, let's see if it's not just this one client, see if we can reproduce it in others. But in order to do that, I would need the help of kind of my coworkers. And if you've ever tried to enlist the help of other people, you really need to make it easy on them to do so. So I wrote the initial kind of like bare bones of Pre2k for them to run in environments. And for a couple months, I just had them test and then give me the results. They'd pull back all the LDAP attributes to kind of corroborate all this information. And the results of that were pretty shocking. So anytime I've heard someone had an internal test, whether it was like a comprehensive or targeted, whatever it may be, I was like, hey, can you try this? Can you do this? And the results were that out of every 10, at least 7 of them had a valid credential in this manner. So, and it was the same results. We had different UAC values, multiple logon counts. So this is, rather than just being like an outlier, it seemed to be the result of all this was a very systemic problem. So it's kind of spread out. So I took the script for Pre2k and I tried to make it kind of an all-in-one tool. So we mentioned that we did this from that unauthenticated approach. So it has 2 modules. It'll be authenticated and then unauthenticated. So the authenticated approach is going to have 2 options. So you can do a query for every single object in the domain, almost like you're auditing it. So it'll grab every computer and guess for each one of those. And then it has a flag available called just targeted, where it's going to use the LDAP query that Oddvar had mentioned, where logon count 0 and then 4128. The unauthenticated will take a list of host names, parse it, and concatenate it in the way it needs to be. And then since it is Python, it's incredibly slow. So if you were to take the Kerberos option, which is written in Go, which is really fast, and compare it to what I had with Pre2k, it blow it out of the water. So added some threading to try to alleviate some of that pain point there. But then on the opposite end, I added the option to have a sleep and jitter function because I mean, this is password spraying. You're not going to run it on any kind of evasive or OPSEC-focused engagement. But if you had to, the option to sleep it down or not sleep it, but the option to slow it down and then have some variance to how often you're guessing the password is available. Also, I really wanted it to be one stop. So if you did find a valid credential, because it's limited to Kerberos, it's gonna if you choose to and select save, it'll keep the Kerberos ticket in your current working directory so you can just pivot off and use other tools. And then dependency funds. So I've had some positive feedback that Python is frustrating. So I tried to get around that with poetry. It turns out that was not a perfect solution. So I'm going to try to Dockerize it. And then if you really just don't want to use this version of the tool, I worked with another consultant, Eversync. There is a PowerShell version available, and that links at the bottom here. It does the exact same things that this tool does, and it's just in .NET. Okay, so let's kind of see how it works. So the first approach I'm going to take is it's going to be all authenticated testing. So you have valid credentials in the environment, and now you're just wanting to see if you can gain control over a computer account. Because I think computer accounts are valuable simply because my opinion is that owning one is in itself a privilege escalation, and it can be used in different kinds of attacks. So this is what it would look like if you were to run it with authenticated flag, very similar. I wanted to have timestamps because if you've ever written a port, you really need to have the timestamps. You want to have artifacts for that, so that's there. And then there is also the option to save the results out to a file, so you only have to run it once. So yeah, I'm going to highlight the output file. So it's just, you don't want to have to run things more than one time. And the reason it's there is because I needed to run it more than one time. So, and then unauthenticated. So I kind of skimmed over this. So when I was having users test the unauthenticated approach, it was you SMB null sessions. You wouldn't expect it to be that common, but it turned out it was. So we would get into internal tests, check for the SMB null session, it would be valid. We'd grab all the computers, we'd have our foothold, and we'd honestly move from an unauthenticated perspective to DA in about 15 minutes if like AECS was available. So it was a bizarre time. So so this is just to prove that we have that SMB null session just querying for the password policy with no credentials. And then we'll use netRPC to pull down a list of all the host names, and then we'll just send it. So here's all the host names. It's all split out, and then we'll just use the unauthenticated module. And so it'll read that list of host names and then flip the way the actual all of the characters into lowercase if necessary. There's also kind of a strange nuance with these where if the password is greater than 15 characters, it'll concatenate down to 14. So that was one gotcha that I missed previously. So the initial run with 1100, once I figured that out, turned into 1900. So that number grew just from that one lesson learned. Okay, and then so there's also something interesting too that I didn't touch on in the slides is that there's also the opportunity to create these accounts with zero password, and it's not necessarily made aware to you either. So that's other research. There's other times to talk about that, but in this case, I wanted to demonstrate that flag's available to try with no credential. So we'll create it with DSAdd, and this is one of the culprits for creating them without that credential. And then we'll just do another authenticated approach to it to kind of show you that the result will come back with no password. Jump ahead. And so the account we created with DSAdd with no pass is also a valid credential. Skip ahead. Okay, so and now to show that the credential is valid without a password, we'll just authenticate with getTGT and DSAdd, and the Kerberos ticket will be good to go. It's really strange requesting tickets with no credentials at all, but it works. And what's one more? Oh, okay. So sleep and jitter, yeah. So for this one, the reason I put this in is because I got burned by Vector AI. I didn't think that they would detect guessing for machine accounts, but they did. So you'll see that the jitter, the sleep that I'm adding is 2 seconds, and it's a jitter of 30%. So you'll have that value kind of increasing incrementally. So you'll see it's 2.2, 2.6, 2.04. Obviously, you kind of stretch this out, and it would take a lot longer. But the idea is to have the option of kind of being evasive with things, as evasive as you can be with password guessing. Okay, and then the last piece, I believe, was just kind of showing that you can save that Kerberos ticket once it's found. Okay, I'm gonna skip ahead. So we'll do the authenticated again, but this time there's a couple extra flags that I've included. So there's the text save and then stop on success. So I wanted to have the option to stop once you found a valid one so that you don't save 2,000 Kerberos tickets in your working directory. So it'll hit the brakes as soon as it's found one. It's not perfect. You'll see even in the demo it'll save 2 valid credentials. But the Kerberos tickets are now in your current working directory to kind of show that you can not just grab a ticket, but actually perform some kind of like lateral movement type stuff. You can use that Kerberos ticket to then Kerberos. So, and that's the Kerberos ticket for my roast me account in my domain. So, that's the demo for the tool. But I did want to share some other cool research that's been done since then. And Tom Tervort, you might recognize that name from he found Zero Logon. So he did the research for Zero Logon. And a couple months ago, he shared this white paper called Time Roasting, Trust Roasting, and Computer Spraying. And what happened in that blog is he dumped in TDDS, and then he just brute force all the characters, and was starting to see that some of the computers had these same issues where the machine account was the same as the host name. But he got kind of even cooler with it, is that he could coerce authentication using NTP to grab a NTP hash for a computer account, but you're limited on your visibility. All you get with that is the computer account's RID, and then, but in theory, you could guess the key space for the computer accounts, and then the password would then be the host name, and you could get a valid credential that way. So that's pretty cool. Also, Adam Chester took another approach to the evasive kind of idea here, is that if ultimately they are accounts with SPN, so you could Kerber roast machine accounts if you wanted to. If you look at any of the source code for the Kerber roasting tools, this is kind of avoided. It filters them out. Adam's idea was, you know, if I'm suspicious that these are Pre2k, let's Kerber roast the machine account, and then you should be able to crack the Kerber roast ticket relatively easy if it's that lowercase password. So, and then finally, Dirkon Malema found, he read through Oddvar's post and found that there's some lingering ACL issues when you create these accounts. So you may have seen, I'm going to go back to that slide. There is the user group right here where it shows you, this is an ACL that says who can join this object to the domain. If you were to change this and say, again, grant it to like a user or another security group, when you join it to the domain and if it's moved around, that ACL kind of persists. It's not an owner, but it does grant you the right to do so. So these accounts that are configured in this manner, if you were to find them and gain control over them, you could, in theory, and they were live on the network, you could, in theory, compromise it and RBCD against that host. So really cool blog, really cool research that he had performed there. But cool, I made good time. Was there any questions over my speed run of that talk? So the question was, when performing the password spray, is it basically doing like a DNS round robin for all the domain controllers in the environment? Unfortunately, no. It's only focused on one DC because a lot of the times I'm proxying it in, so I can't really perform that round robin. So unfortunately, no. It would be nice though. Question was, any plans to port this to Go? And the short answer is no. No, sir. Thank you for the question. But anyone else? Nah, cool. Thanks, guys. Appreciate it.